So that's right. We go right through the rainbow except for purple. So here we go. On today's show, I want to do a little bit, we want to put the improper in improper integrals. So here we go. Let R be the region in quadrant 1 under y equals x e to the negative x over 2. Y equals x e to the negative x over 2. And just for the folks at home who've never seen a picture of such a thing, here we go. We'll do a picture of it. That's not it. We'll do a picture of it. Sorry, folks at home. I'm killing your lesson. There it is. And there it is. There it is. And we'll zoom in. Oh, we'll do a zoom box. I love the zoom box. Who is it? I actually do have a counter that I can take a look at the counter and see how many people have seen the videos. Absolutely. I should. Somebody does, but not me. Somebody gets IP addresses, but not me. I don't have that kind of access. So here's what I want to do. I want to find that area. And to find that area, I want to express that area. Here's R. I want to express that area as an improper integral because I'm pretty sure that you know that that area is, that perimeter is unbounded. That goes all the way through to x equals infinity if infinity were a number. So if I want to express the area as an integral, how do I do it? Integral 0 to infinity of that. Now, you and I are both aware that if we were to find an antiderivative and try to sub, and subtract, the issue becomes you can't plug in infinity because infinity is not a number. Like you remember when you were little kids and you sat on your front stoop and you played what's the biggest number you can think of? And somebody said infinity and the next person always said infinity plus 1, remember? No, you don't remember. You never had friends when you were young, which is just like me. So what we do instead is we say, look, I think every time I did this, I looked right at you, Brendan, so I'm going to do it right now. What we do is we say, I'm not going to go to infinity, I'm going to go to b. I'm going to take the integral from 0 to b, and then I'm going to control the growth of b. I'm a control freak. So I'm going to, it's true, I'm going to control the growth of b. So we integrate from 0 to b and take a limit as b approaches infinity. That's how you have to answer it in a free response section. You have to answer it by showing limit of a definite integral. So here's what we're going to do. We're going to come up with an antiderivative, sub, and subtract. Integration by parts. Now, integration by parts, let's use the tabular shortcut. In the tabular shortcut, we go derivatives down the one side and then antiderivatives down the other. So I need an antiderivative of e to the negative x over 2. Wow. Wow. So remember that the derivative of e to the something is e to the something times derivative of that something. So we need a negative 2 out here to compensate for the negative 1/2 that's coming down. And then this is another e to the negative x over 2 with a 4 right there. And then we remember everybody holds hands. These guys hold hands and keep the sign, Wardy. Oh, the derivative of e to the something is e to the something. So when I go from here to here, and you folks at home can't see that, when I go from here to here, I want to have a negative 2 in front, because when I check myself by taking a derivative the other way, I've got a negative 1/2 that's coming down. Remember, when we take a derivative, we multiply by the derivative of that argument up top. So there's going to be a negative 1/2 coming down. I've got to neutralize that, and negative 2 is the thing that neutralizes that. Cool. So back to integration by parts. Those first two guys hold hands with a plus sign. The second two guys hold hands with a minus sign. We're out of people to hold hands because 0 isn't really a number. And so we've got negative 2x e to the negative x over 2 minus 4e to the negative x over 2. Now this should be fun. I want to find that limit as b approaches infinity. So here we go. We're going to substitute b, and if we substitute b, we get that. Oh, no. And that. And then we subtract out what we get when we sub in 0. So I'm pretty sure I know 3 of these things. I'm pretty sure that the 4 is still a 4, and the 0 is still a 0, and I'm even pretty sure that I know this one. What happens as b gets large? 0. So the trick is, what happens here as b gets large? The top gets infinitely large. The bottom gets infinitely large. But it gets infinitely large faster. If you're not satisfied with that explanation, and you may not be, right, if you're not satisfied with that, and you may not be, L'Hopital's rule will get you 0. Remember what L'Hopital's rule says? It says you take the derivative of the numerator, the derivative of the denominator, and try again. So we'd have negative 2 over very big, and that reduces to 0. And so we can find that area. That area is 4. If it were a calculator active question, and it's not, but if it were, I could do second calc, find an integral from 0 to as far out as, oh, I can't do that. Okay, so I got to pick something a little bit smaller that's within the window, and I say, wow, that's close to 4, and then I could make my window really, really large and try to estimate what I think it would be. But it's not active, so you can't. There it is. The hamster is very, very good at shading. There you go, and that's that.